welcome back. So we are still busy with components, okay? Now, last time, well, in the last section, we looked at vertical components, horizontal components, parallel, and perpendicular. Now we need to do a question, okay? So the question is going to be about what happens when we have two forces on an object. So I showed you with one force, but how do we use these vertical and horizontal components? And the whole point of them is to find a net force, okay? That's what we're looking for. So here's what we've got. I've got two forces acting on an object. One is 120 newtons bearing 70 degrees. The other is 160 newtons bearing 40 degrees. The question is to find the net force. In other words, what's the result of these two forces if I put them together? We need a diagram, okay? So let's see how they look on a diagram. Bearing means that I'm measuring like a compass. So I'm going from north, which is 0, and I'm measuring an angle of 70 degrees. This is different from maths. In maths, your 0 is horizontal. For bearing, this is from geography, your north 0 is at the top, okay? So we have this. We have, I'm just going to give my bearing lines. My first force is 120 newtons bearing 70 degrees. So it would be 70 degrees and it's here. So there's my first force, and that angle there is 70. Okay? The second one, and I'm going to use this just so you can see the difference, is 40 degrees. So it goes there. And that's 160. I should have drawn my diagram a little lower because that's not big enough, but it's all right. There's F2, and that angle is 40. Now what I want to know is what's the resultant, what's the net force. So in other words, if I took those two forces away and I put a single force that will do exactly the same thing, where is it? I don't want a diagram. I want us to use components, okay? So that means I'm going to take the first one, F1, split it up into two components. Then I'm going to take the second one, and I'm also going to split it up. And then we'll do the next step. So step 1, split them up into two components. Keep drawing diagrams. I know sometimes we go, oh, but they're not for marks, I don't want to. But do it. Because remember, when you draw a diagram, you're not going to make a mistake. And even for us to sit and go, no, I can imagine it, I can see it in my head, sometimes our imagination doesn't work so well. Okay, so let's go back. Let's do F1, okay? So F1 is there. I haven't done it quite to scale. This is going to make it easier. This was 70 degrees. We can use the 70, doesn't matter, but we generally go from the horizontal. So let's make sure that you know what that means. This angle, the two sides, the vertical and horizontal, are 90 degrees to each other, so this is 20. Be careful. I see that as 30 often, okay? We have vertical component. Now, I'm working with two forces, F1 and F2. I need to make sure I remember which vertical and which horizontal goes with each. So this is going to be F1 vertical, and this one here is going to be F1 horizontal. That way, that means once I've got them, I know which one's which. It's easier for me to work with, okay? Let's start with the horizontal. Horizontal is adjacent. That means I'm going to use cos. So, cos, I'm going to go straight here. So my horizontal is F cos theta, okay? If you want to go cos theta, is a horizontal over F, that's fine, doesn't matter. We need to work it out. F1 was 120, so that's 120. We're using 20 degrees. Now, my maths is good, but I can't do this in my head, so we're going to use the calculator. Okay, so remember, we're doing 120, okay, 120 times cos, and our angle was 20 degrees. Don't forget to close your bracket. And we get 112,76. Your instructions in any exam round off to at least 2 decimal places. You can use more, but 2 is fine. So it's 112,76, okay? So now I'm going to put it here. 112,76 newtons. It's a vector, which means I need direction. If I look at this, this was bearing, okay? I need to say bearing 90 degrees, because this is the 90 is here. Okay, so here, bearing 90. Okay, there's no marks for this bearing answer yet, but I need it for later on. I've got to keep track of all the directions, okay? So, and I'm not sure why that ended up on this side, but it's all right. We'll go with it. What I'm going to quickly do is take this out so that I can do the horizontal, the vertical here. Okay, now we're going to do the vertical. There we go. So now, over here, vertical is opposite. So F1 vertical is F. Opposite means sine theta. So now we're going to do 120. I don't know why I'm putting a degree sign there, because there isn't a degree. So let's take that out. No degree there, but it's sine 20. And again, we'll need the calculator. Okay. So let's just clear that, because that's not what I'm doing anymore. So now this is 120, whoopsie, extra numbers, 120, sine 20, and it's 41,04. Okay, I'm not going to use the 2, doesn't actually matter. So this is now, oh, there we go, 41,02 newtons. But this is now up, so this is bearing 0. We good? We've only found the components of the first one. Now we need to do the second one, okay? So the thing about these questions is they're long, but we get a very accurate answer. So F2, let's just remind ourselves, was 160, and this angle was 40 degrees. Okay, so that's the way it looked. Now when we do our components, we're going to have F2 horizontal, F2 vertical. What do I need? I need the angle in the middle, so we remember that they're perpendicular. That makes this angle 50. Okay, be careful with that. Be very careful. Starting with the vertical, it's opposite, so we're going to use sine. So F2 vertical is F2 sine theta. So that means, and again, oopsie, sorry about that. Let's just go back to where we were. Having fun with the board today. I put a degree sign in there, and I don't know why. So let's just take that out, because we should. And so this is sine 50. That's where the degree goes. Calculator. Okay, let's get rid of what we had there. So now this is 160, and it's sine 50, and it's 122,57, because that's 67. It's going to round up. So, okay, I'm too fast for the board. That's what's happening. Now I've forgotten what the answer is. There we go. 122,57. 122,57 newtons. This vertical is also up, so it's bearing 0. Okay, so it's vertically up. So now we've done the vertical. Now we need to do the horizontal. Horizontal is adjacent, so we're going to use cos. So F2 horizontal is going to be F2 cos theta, which is 160 times cos 50. Going to use the calculator. Okay, so now we're going to get rid of that. So we have 160 cos 50, close the bracket, 102,85. Now I'm going to try remember that. 102,85. There we go. Stop it. 2,85. Which direction? Bearing 90 degrees. Okay, so right now, some of you are looking at this and going, that's nice. You haven't gone anywhere. I actually have. Okay, so what we have found out is this. We have a vertical component from the first force that's bearing 0 degrees, going up. We have a vertical component from the second force that's also bearing up, going upwards. We have a horizontal force from the first one, which is going 90 degrees. And we have a horizontal force from the second one that's also going at 90 degrees. Now, I've drawn them the same size, but they're not the same size. I'm not worried about that. It's about the direction. I can now take these 4 forces and make them into 2. Because what we're going to do now is I'm going to take those 2 vertical forces and I'm going to add them together. I'm going to take those 2 vertical forces, horizontal forces, and I'm going to add them together. I'm going to find a resultant of those 2, okay? So I'm going to take that away because I'm sort of running out of space, okay? I want to keep these values that I've got over here so that you remember them. Those 2 go in the same direction, so this is what we're going to do. I'm just going to get rid of this because I don't need this now. So what I'm finding is the first thing I'm going to find is F net vertical. So I'm going to add my first vertical with my second vertical. Now the first vertical we worked out earlier to be 41,22. This vertical is 122,57. Now, at this point, you are welcome to do that in your head. However, in an exam, you normally get quite stressed. So use your calculator, okay? Okay, so we got 41.22 plus 122.57. And no fractions, we don't like fractions. So this gives me 163,79 newtons. It's a vector, so I need a direction. And this one was the vertical one, so this is bearing 0 degrees. All right, we've done the net vertical. Now we need to do the net horizontal. So that I'm going to do now. I don't need this answer anymore. And you doing this all nice and neatly in your notes underneath each other. And we don't need this anymore either, so let's get rid of this. All right. So, net horizontal, which means I'm going to add the first horizontal with the second horizontal. The first horizontal we worked out to be 112,76. The second one is 102,85. We're going to add these together. Let's move this so that we can actually see it nicely. So we've got 112.76 plus 102.85. Again, can't use fractions, make sure it's a decimal, so we have 215.61. So 215.61 bearing 90 degrees. And once again, you are probably still looking at me and going, really? We still haven't finished. No, we're not. But we're almost done, because now we're going to old-fashioned vectors. What have we actually worked out? Well, now we know that we have a vertical force that goes up of 163.79, and I have a horizontal one of 215.61, and I can find the resultant. My resultant is there. So I want F net. Let's make that F actually look like an F and not, I don't know what that looked like. It's a right angle triangle. We're going to use trig. Now, we are going to use Pythagoras to find F net. And then we are finally done. So, let's use Pythagoras square of the hypotenuse. So that's F net squared is the sum of the square of the opposite two sides, horizontal. And actually, I don't need the 1 and the 2 there because we're using the net values here, okay? So we really should put net there. The only thing with this section is it gets a little horrible with all the writing. Like, things get big, but it doesn't matter. So my vertical was 163.79. My horizontal was 215.61. Okay, I definitely can't do this in my head. So let's put this in the calculator. So we're going to go 163.79 squared plus 215.61 squared. There, oh, no, or not. Let's do that again. 163.79 squared plus 215.61 squared. We have an answer, but I need to square root it. So I'm going to square root the answer. And I get 270.77. Again. Oh. All right. 200. Let's just check again. 70.77. One last thing, because we're not done yet, but I promise this is the last thing. We're working with vectors. Vectors mean that we need an angle, we need a direction. So we need to know theta. Right angle triangle, we're going to use the opposite and the adjacent, so we're going to use tan. So tan theta, my opposite, which is my horizontal, over my adjacent, which is the vertical. So tan theta is going to be 215.61 divided by 163.79. All right, so back to our calculator. We're going to use second function tan because we need tan to the minus 1. We're going to put in the right numbers, 215.61 divided by 163.79. Close your brackets, don't forget to do that. Gives us 52,78 degrees. Okay, so we have 52,78 degrees. We need to write it as a sentence. So my F net, 270,77 newtons, bearing 52,78 degrees. And now after that very long question, we all deserve a break. So I'll see you in a bit.